start. Will it work? I hope it will. Boom, 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 boom. Boom, 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 boom. Yes, it works. Hello, YouTube. It is Sunday. It is my birthday, and so I decided to just do a small stream where we are going to work on some shaders and explore a technique to basically transition or play around with alpha values based on an input texture. Vex, thank you so much. And welcome. I hope you're doing good. So, I can tell you one thing. We don't need the vertex at all, right? We are going to need a sampler 2D to... I'm going to call it transition mask, because I don't know if it's really seen as a mask, but why not? This is going to be the input. And then we want the progress, which is a float, right? Progress float. We can hint range. I like to have a better range like that. Okay, the first thing I can do right away is create a transition mask, right? So I can grab that, create a texture. Did I pin this? Unpin this message, yeah, okay. Sorry, I did something. And, okay. It doesn't have to be big, right? And we can have like a wipe from left to right. It's going to start from the beginning. It's going to start from the right, I think. And so the idea was you compare the texture. So if we could actually put it directly into a float, right? We could read the mask. Chris Franklin on YouTube, thank you for the follow. Have you had a good day so far? Yeah. I was with friends yesterday to celebrate, and tomorrow still with some friends, and then a bit more chill. So yeah, pretty cool. I'm still a bit sick, but it's getting better, so that's good. I played a bit also. I played a rage game that released recently, which is called Driving is Hard, something like that. It's pretty fun. So yeah, pretty cool. Mask value. Let's call it mask value. And so I will texture the transition mask. And I guess I will just read UV, and so I will grab a value, but it doesn't matter because it's grayscale, so you can take RG or B, right? You can just take RG or B, it doesn't matter. And then we could put into the color A. In here, this is where we need to transition, so we do a comparison. We do a comparison between our mask value and the progress, right? Is that what I want? And so my progress is this. Do I want it in that order? Not sure. There is something missing in here. Right? It doesn't preserve my alpha initially. So I need to have color.a, the input, and now it preserves my alpha, right? So this is a pretty simple technique. Is it in that order that I want? Do I want progress to be like that? It could be 1 minus, depends how you see things. So it's a very simple shader, right? It's a very, very simple shader. The thing about that is now the code will be always the same, and the transition is basically decided on what is the input, what kind of transition mask you create. And so if I, for example, put the transition masks to be like that, to be diagonal, right? If I put it to be diagonal, what happens? Boom. Diagonal. Isn't it incredibly simple, elegant, and wonderful? Elefundo, happy birthday. Thank you so much. Thank you. Thank you. Hope you're having a good day. Look at that. So now what we can do, we can filter. Sorry, I'm fill. I want radial now, right? I put that in the middle, and now boom, we have a circle filter. So the problem with our circle filter, is that we would need to create a circle, like maybe make it like this, but it will never be big enough. The circle would need to be bigger. Interesting. How do you deal with that? If the mask is not the size of the image, you might be stuck, right? You need to be able to go above the UVs that you have eventually. You see what I mean? Otherwise you have that clipping at the end, which doesn't really work. But that's pretty cool. So that would be a transition mask with a relatively simple transition. Anyway, let's go back to radial. What does square does? Oh, square. Actually pretty cool, square. Look at that. It's not as interesting as I thought it would be. Why is it not as interesting as I thought? I don't know. This resembles because this is too small of a value to really see something. Fuck, this is so easy. This is really cool, right? So let's go back to linear and let's go back to our linear wipe, and like that. So that would be one example, okay? One example. Let's duplicate the icon and let's try something a bit better. So for that, we would need some textures. Thankfully, we can either create some cool texture, or we can use Voronoi noise, for example. Can we create Voronoi? Can we create Voronoi noise? Make unique? No, I said clear. Fuck's sake. Canvas item. I don't want canvas item. I want new shader item, and I want new shader load. Okay. In here, am I able to create noise texture? Yes. What kind of noise can I create? I can do some cellular noise, which should be not too far from what we need, right? The texture size could be much smaller, I feel like. 256. I don't think it has to be that big. Color ramp, we don't care. Fractal, cellular, Euclidean, Manhattan, I don't know those things. I have no idea about those things. Cell value, ooh, this is cool. Distance add, distance 2, distance multiply, distance division. Ooh, this looks nice. Let's go with cell value, right? I really like that. Hey, Tim, thank you so much. Welcome. Weighted strength, okay. Lacunarity does that. Why it looks like we have two values on top of each other. You see what I mean? Oh, it's because of the FBM. Oh, okay, interesting. So I keep an FBM of 1, rigged. ridged, sorry, and ping pong. Okay, let's take an FBM of 1. Can I jitter? Oh my god, this is fucking cool. What the fuck? This is so cool. Gain, I don't care. And then I will change the frequency to have something a bit more like that. And so now what I can do is play around with this, which creates some sort of painterly effect. Like it creates like a how would you call that? Like a right on or something. Or not at the best. Yeah, it looks pretty cool, right? So what I would like now, I like the fact that there is a bit of spill. You see what I mean? There is a bit of spill. And so you have some progress before you actually have a new cell completely filled in. You see how the cell is getting slightly smaller and then it fills in entirely. This is actually pretty cool. And so what I find incredibly interesting is that we can have some really cool effects by playing around with jitter like that. So if because I'm seeing this now, I feel like Dubio, because what inspired me to make those shaders and stuff is this game. So I played this game recently. I talk about it every time I stream. This is a very cool game. It's called Dubio. It's like a puzzle game, but based on speed and momentum a bit. Very interesting game. I enjoyed it very much. And what I liked a lot about this game is the visuals. Visuals are super simple, very, very neat, and they have this shader for the entirety of the game, like all of the outside. And you can see how they're using this shader in many different scenarios where the shader is used differently everywhere. It's just really cool. You see how it's like revealing some stuff. I really like that. And they're using the same shader everywhere. And sometimes the shader is animated. Sometimes the shader is based on like how close you are to it. Sometimes it gets removed over time. Sometimes it's just moving. And this is freaking cool. Like, I really enjoy it, right? It's a really cool shader. And when we talked about it, Smax told us it's probably just like a how can I say that? I don't have a good way for that. Like a transition texture, or a you could call it a mask texture, I guess, something like that. A lookup texture for revealing stuff. And now that I'm seeing the fact that you can play around with jitter like that, so if jitter is equal to 0, it's perfectly squared, right? Look at that. If jitter is equal to 1, this is perfectly squared. But then you can play around with jitter and like turn stuff. Is it Voronoi based? Maybe not entirely. I think it's still different. Mike, thank you so much. Happy birthday. Thank you. 11 months in a row. Let's go. Thank you so much for the support. Euclidean squared. Manhattan. Okay, Manhattan is more I don't know. It's more hybrid. Euclidean. Okay. I like that. I really like that. Weighted strength, I don't care. Linearity, I don't care. So domain wrap enabled. I don't need it in here. This looks very paint-like, right? If I do this, but I don't think I want this. Simplex, amplitude. I don't think I want that. Frequency, more or less. Yeah, it doesn't look like what I want. It's shader time. It is. So what I like about Voronoi based is the randomness in the shapes and stuff. What I don't like is the fact that it's full color. It's a full color. It's not a gradient, and I would like a gradient because a gradient would allow us to do more cool stuff. Unfortunately, I can't do anything about that right now. I can play around with this, change the color if you want, but it doesn't matter because we're not doing anything. So I think I would need to create the Voronoi myself to be able to inject gradients in the colors. Right? Or I multiply that noise with a gradient, but it's not going to do what I think it's going to do, right? Let me check. Uniform sampler 2D, and I would call that gradient overlay mask. I don't know if this is what I want, but you get the idea. I create a new gradient texture that I keep very simple like this. And so now my mask value can be that multiplied by basically the same thing. It's mask, not masl. Mask. Right? And so I create my gradient texture. It's not doing exactly what I thought it would be doing. We have the wipe. It's just that the wipe gets applied on the Voronoi, but not the way I want. Hey, Fruit Superman, thank you, welcome. You see what I mean? Doesn't really do what I want. If we go on Godot shaders, there is something to create Voronoi. Sorry, I need to mush myself. Give me a second. I need to look at the snippets, I guess. I need to look at the snippets, and somewhere they're doing procedural Voronoi and Whirly. Let's go. If you want the patterns to move, you can add this to the loop. I don't think I want them to move necessarily right now. So let's look at what they're doing. So random whirly, and then they use in here whirly stuff. Let's look at that, shall we? Okay, that way we have an idea. Whirly Voronoi diagram. With the whirly noise as a base, you can make a Voronoi diagram. Instead of the fading distance value, each cell gets its own defined value. This is more what I want, right? I don't really care about that. Do I need the other thing? Random. I need the random. I need the random. How old are you now? I'm 29. Can you believe it? Can you believe it? Redefinition of fragment. You are the fragment. You are the fragment. And I'm not redefining you. Okay. What is interesting is that it looks squished. Right? Don't you think it looks squished? Because we are not providing the same amount of rows and things. Okay, so now we are back to Voronoi, right? We are back to Voronoi, the same way we were creating our noise texture in here. But, eventually, we could figure out how to provide a gradient. But is it really going to do what I want? Huh. The gradient would have to be closer to... Can I multiply by my gradient overlay mask instead of having just a value? I'm returning the minimum point in here, Voronoi, and I'm using that Voronoi value. I'm creating a vector based on that. So what happens if I multiply that by my gradient overlay mask, R? Sorry, I need to texture it that way. It's not what I want. It is not what I want. Not at all. Not at all what I want. Not at all what I want. Because I want the whole gradient. I want the whole gradient to be mapped in the cell. You see what I mean? I want the whole gradient to be mapped in the cell. And I have no idea how to do that. No freaking idea. Because what I could do in here, instead of grabbing the mask value, I could have the Voronoi. We are creating a vector 3 in here. It's stupid, but you get the point, right? And we would go back to what we had earlier, where we can remove part of it. But of course, I would need to not do that. This is not what I want. You don't have steps in here, you see what I mean? Maybe subtract it. Subtract it? I don't think it would work. I don't think it would work. I don't think it would work, unfortunately. This should be make unique. That way I can do my own stuff in here. And in here, I would not use Voronoi, whatever. Yeah, I will have my simplest one that takes in a value, and then I have the Voronoi one. Let's put the Voronoi one somewhere here. Let's duplicate this bad boy. Let's use the mask value in here. In R. Yes, transition mask. This is the one. Gradient matte overlay mask. No, I don't want that anymore. I don't want that anymore. And so, just as a test, in here I wanted to see a shader material make unique. Shader parameter. What if the cool thing about that is you can get quite crazy with the value, right? And then based on the interpolation that you have, you would have different result. But in here, that allows you to do some stuff like that, which is pretty cool. Some stuff like that. Like a wipe. This is pretty cool, right? Could have something much more simple. That would be white. That would be black. Black. And you would have the transition from here and here. This is so fucking useful. You see what I mean? This is so fucking useful. You really have something... Noise texture, incredibly powerful. Perlin noise. No, let's go back to cellular. I just wanted to try something else with cellular. What did we do earlier to change the type? Return type, cell value. This is this. Distance. Distance mold, distance div. Distance div is pretty cool also. Right. This is really interesting how the octaves are just basically a bunch of stuff on top of. You can really see it's like overlaying multiple noises. Create something really interesting. Like narrative doesn't really do anything. Very cool. Whoops. Ping pong. None. FBM. Okay. But this is too... Yeah, because of how it's mapped, it looks very fast. It looks very organic. This is too organic for my taste, but this is a pretty cool feature. I can see how you could use that as a way to create a noise, a shader, an ice shader or something. You see how it somehow looks like you could imagine having like different refraction and stuff based on where you are. This could work quite well, I feel like. What I don't like is initially it looks very cool. It looks interesting. The shapes are interesting, but very fast. It's super round. I found that less interesting. Hey, E5, hello. You see what I mean? Unfortunately, this is pretty cool. This is very cool. Needs a random element. What do you mean? What do you mean? Gradient Voronoi. Do you think there is someone that has a gradient Voronoi somewhere? Oh my god. Oh my fucking god. What? This is perfect. This is exactly what I want. Ho 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 ho. Oh, this is so cool. Oh, this is really cool. Ho 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 ho. Do I just steal the image? Do I just steal the image? Maybe. Give me a second. I might start with stealing the image and then we might try to do it. That way I see if it's useful. Gradient Voronoi. Okay. Hey, thank you for the cheers! Thank you, E5. I mean, if you want the dissolve to be less uniform, a random element might achieve that. That's true. My problem was... I don't know. I don't know what my problem was. Imaginez vivre encore 1 an sans essayer de cacher votre nationalité française. Je suppose que certaines personnes acceptent les difficultés de la vie. Yes, Peacebreaker, we do. We doodly do. Welcome, Peacebreaker, and thank you for telling me happy birthday in a very simple manner. Thank you for that. This is really shit to be precise, right? I want to keep it aspect ratio of 1. Hey! Peacebreaker, thank you so much for the 5 gifted subs. You gifted 105 subs on this channel. Thank you so much. Etherblood, Piorgi, Justice, Frozer, and G-Cup. Enjoy your subs. Thank you so much, Peacebreaker. Peacebreaker breaking the peace. Totally. Joyeux anniversaire, chef. Merci. Merci, merci, merci. This is incredibly shit. Okay, keep it square. Is it okay? Save option, save. There is still something on the side, right? 105, sheesh. Yeah, I can see they gifted 105 subs on this channel. Birthday hype. Thank you so much, Vex, for the 100 bits. Thank you so much. Okay, now that we have that, let's put it in here. Thank you, guys. Oh, also, look at that. Look at that. I talked about it on... I posted it on socials, but... Look at this. 1 million views on Ellipteach. I just got the message today. 1 million views on Ellipteach. My second YouTube channel has reached 1 million views. E5, thank you so much for the 42 bits. Is this the answer to life? Is this the answer to life? GG. Yeah, that's pretty cool, right? I never realized that I was making quite a lot of views on that channel, and in fact, I have some videos with around. I think my most viewed videos on that second one has like 200k views or something. It's doing pretty good, yeah. And on average, the views are pretty high. I'm happy with this second channel. But yeah, pretty cool. And I decided to keep the revenue on. I decided to not hide it because I thought, you know what, some people might find it useful to know how much a channel like that can generate in revenue. Of course, when you think about the amount of time required to make a channel like this, 1,000 might seem like a lot, but it's very, very shit. You see, it's very shit. It's very underpaid, but I mean, it's always some money in the bank, so that's cool. But yeah, 1 million views, pretty cool. Guys, we have something. I need to try it now. And we are at hype train level 2. Let's go. I should have a scene for a hype train. I should have a scene for that. A nice little scene with a train or something. I like the fact it's 1K precisely. Yeah, it's very precise. Influencer YouTube channels and stuff. It's always much more work behind it. Yeah, exactly. And also game dev channels. It's not a niche that pays very well because I guess it's a lot of very often it's a young audience, and so the ads are not bringing a lot of money. If you compare that to something like tech or finance and stuff, it pays way more. But it's still pretty cool. Okay, grayscale transition. I will put that in here. My JPEG. And so now, would you look at this? We are going to grab this icon, put it in here. And let's put in here, not this transition mask, but this transition mask. Oh shit, it's the same material, make unique. It's the same material. Why do I see the hype train? Oh, because it's the percentage. Did you achieve the circle one? I was gone when you tried to do it. No, I didn't try. I think to achieve the circle one, what I need is a way to scale the input mask. Maybe we can do that if you want. I can do that. Basically, what I need is to scale the input mask to make the input mask, the transition mask, to make it bigger than the actual image. That way the circle goes outside of the image, because right now it doesn't. Happy birthday. I'm not going to try to pronounce that. Joyeux anniversaire. Thank you so much, Camilos. Hope you're doing good. And thank you for the hype train, guys. We reached level 2. Peacebreaker and Vex were the conductors. And of course, thank you, E5, for your bits. So yeah, we can try that. What did you do for your birthday? Yesterday I was with friends. I got friends at home. We had a nice little birthday party. It was pretty cool. And then today I was still with friends a bit, and then a bit more chill. I played some games, and was sick because I'm still sick. But yeah, pretty chill. I'm happy. Look at that. This is going to be much closer to what I wanted. Yes. This is much closer to what I wanted. You see how now it's much more interesting? Okay. Follow me, Patreon, really cool stuff, and also for learning. Yes, you're right. Don't hesitate to check the Patreon. And also there's a free post about recommendations. Just wanted to say, you look a little bit sick. I am sick. That's why. What I could do in here... but my transition mask now is fixed. Because it's an image, it's fixed. I'm not sure how they're achieving. I'm not sure how they're achieving that look. There must be something else, right? First of all, it's much more like a square. Right? It's much more like a square. so fucking cool. The look is so fucking cool. It really shows you that you don't need to be necessarily an artist to make something. And when I mean an artist, I mean in the classical sense. Like, you don't need to know how to draw to make a beautiful game. If you have the right technique, and of course you need also an eye for colors and stuff. That you can't get away from that. But you can really make something super cool like that. So this to me, because it's rotating, it must be a shader. It can't be an image. It can't be a static image. You see what I mean? Because look at that. In here you can see that the transitions when it's yellow. In here you can see the transition is rotating, which means with this you can see, right, how it's rotating. I don't think it can be a static image to achieve that. It can't be, right? Otherwise it wouldn't be able to rotate, and that's kind of the problem that we have with this shader in here. That's kind of the problem that we have, is that it's very cool, it's a cool effect, but first of all, I don't have any control. Like, the entire image has to move, and also I don't have control on what is the orientation, because it's a static image. It's not noise that I'm generating. Whereas with this one, because we are creating the noise, we can play around, for example, but jitter is not exactly what I want, right? Jitter is not exactly what I want. It creates some rotation, but it's not that. Wow. What I would like is to find a way to create a gradient in each of the cell. I would love to be able to do that. And because then maybe we would be able to rotate that gradient. But I think it's a bit out of my league. But let's do the circle. Let's do the circle, right? Let's do the circle one that we talked about earlier. So let's go in here. Let's go in here. Let's do material. I'm gonna make that unique. I'm gonna put, as an input, I'm gonna create a gradient texture, which will be like that. Is that what I want? Is that what I want? I don't care about that. I want radial. And what I need is something that is not used. Keepity bop. Is it, am I looking at this? No. Let's have more in here. That way I can do that. Okay. Is this passive star theme? Those inspector icon looks weird. Yeah. It is the theme from passive star, and some of the icons are slightly weird. Yes, that's true. But also I'm using. Maybe that's why I put the thing into auto dark mode. So I don't think the theme looks exactly like the one from passive star. But the cool thing is that it's able to be white during the day. The other Zek looks like some classic UV trickery. Use the Voronoi cell to produce a UV map for the gradient, then use the cell ID to influence the gradient rotation and offset inside the cell. Yes, I think that's what I want to do. I'm just not sure if I will manage to do that, but yes. That would be the idea. Let's just make the circle really quickly, right? Let's try the circle. So you see, my problem is that basically, as soon as I'm above the value, as soon as I'm above a certain value, it clips to a full circle. So my idea is, can I just uniform? Can I just uniform? Am I in the right thingy? Am I on the right shader? Yes. can I just uniform float UV scale? Can I just use UV scale? I don't want some hint range or anything. By default it's 1. By default it's 1. And can I just UV times UV scale, right? So by default it doesn't do anything. It's perfect. And now if I'm here, it doesn't scale from the center. So we need to do the center stuff. Vec2 centered UV. How do we do centered UV? How do we do centered UV? Do you know? There's something that we need to add something, divide by 2, whatever. Scale from center. Ah, yeah, you need to convert. So you do divided, multiply by 2 minus 1. Then you have you centered UV. You scale to the UV and you convert it back. Centered UV multiply equal the scale. And you convert it back. Vec2 final UV, I'm going to call it, because I don't know. I'm going to use my centered UV in here. And I'm going to use my final UV. Is that correct? And so now, okay, that is okay. Let's go right before. Let's go. Would you look at that? Perfect. 2 times UV minus 1. Exactly, that's what I want. You want to have it in minus 1 squared. I don't know. But I wanted to have it centered, and that's exactly what it did, so that's cool. So now the cool thing is that I basically make my UV scale big enough so that it goes above my texture. So you can see, right there, the circle is basically around here, and so now I have my circle wipe correct. It works fine, right? Is there a better way to do this? I don't think so. Because you have a circle and you have a square image, there's not really anything you can do beside making the UV bigger, right? There's nothing else you can do. But now it works fine. Whoop, 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 whoop. So that's pretty cool. So that is fixed. Cool. Cool. I am not sure. I would be able to do the same shader from Dubio though. I am not sure, but we can try. So the Voronoi, custom Voronoi is this one, right? The Voronoi is this one, I think, where we created a Voronoi ourselves. No? Can I edit this one? Oh yeah, it's this one. Okay. You know what? Let's save it. Let's save it. Save it as grayscale transitions, custom Voronoi. So in here we have our custom Voronoi, and so that's what you talked about, other Zek, right? That's what you talked about. You said we use the Voronoi to produce a UV map for the gradients. Then use the cell IDs to influence the gradient rotation and offset inside the cell. instead of being a full thingy, we would like to have a gradient in here, basically. That's my idea, right? I'm not sure how it works, this gradient stuff. Minimum distance, minimum point. We look at the neighbors. We look at the 4 pixel neighbors, I guess. -1 to 1. Yeah, we look at the 4 pixel neighbors right in here. We get the neighbor. Random index UV x times columns, UVy times rows, plus neighbor, and we get a point. Random diff neighbor plus point minus fract UV. Then we get the distance. We get the distance between our current point and neighbor plus point. Okay, we look at the neighbor, to which we add a point, which is a random point. Minus fract UV. If the distance is inferior to the minimum distance, we create a new minimum distance, and we return the minimum point. I have a feeling, I'm not exactly sure what's happening, but I have a feeling. And my feeling is, in here, we are doing a threshold, basically, right? We are looking at a threshold, and instead of having a threshold, we could have, on top of that, we could use the distance. We could use the distance to compute a gradient, right? So the further away you are from whatever, the bigger we change the color based on that. This is where we get to split hairs about Voronoi diagrams versus Worley noise. The latter is the family of functions used to produce the former, generally as a distance from center gradient. Yes. Good old shaders. Voronoi. I will look at that again, because there was something interesting. Maybe they talk about that. So Worley noise or cellular noise is a distance value pattern where every pixel gets a value based on the distance to the closest point from a defined set. This creates a pattern like the one above. Right? So with Worley cellular noise, we have some sort of gradient, but it's not the way I want. Right? If you want the pattern to move, you can add this to the loop. I don't care about that. The Voronoi. With the Worley noise as a base, we can make a Voronoi diagram. Instead of the fading distance value, each cell gets its own defined value. The Book of Shader talks about that. Maybe there's something else. So in here, how are they doing it? How is it different? They are computing a point, they're getting the distance, and they're returning the minimum between the minimum distance and the distance. I have a hard time visualizing what it does. I have a hard time understanding what this is doing. So if you have one pixel, okay, let's try to figure it out. You have one pixel in here, and you look at the neighbor pixels, right? You look at the neighbor pixels. You get a random point. You take that neighbor, you say, for example, this neighbor in here, and you get a random point using the current index where you are plus the neighbor. And then the difference is the neighbor plus the point minus fract UV, which is the same thing as index UV, no? Oh no, it's fract. The fraction. What is fract? What is fract in here? I need to take a look at that. The question is, how do you convert a radial distance into a sine 2D distance? I have no idea. I have no idea. Arkham, hey there, happy birthday. Thank you, welcome. Hope you're doing good. I think this is slightly above my my level right now. Shaders are a bit black magic. All my best wishes for the years to come, health, joy, and game dev success. Thank you, thank you. I started the year very well. I was sick on New Year's, and I'm slightly sick today, and I've been like for the past 3-4 days. So I'm starting the year in a very healthy position. And then you get the distance. So the difference in here is that the length of the difference, the distance is in here, right? You grab the difference, and in here you take the minimum between the minimum distance and the distance, whereas in here there is a hard threshold. It's not continuous, right? And so this, why does this makes the center be black? Because you are looking, okay, because you are looking at your cell. If you say that you define a cell, yeah, okay, it makes sense. No matter how you define a cell, right? Let's make a square cell. It's just easier for me. No matter how you define a cell, no matter how you define a cell, your each pixel is computing a distance based on the walls, right? In 2D, like that. And so the closer you are to the wall, the closer you are to being white, and the further away you are, which is necessarily the center, you are black, right? So we know that it's doing that with Whirly. Interesting. And what we want is not really that. Is not really that. We would need to have something that tells us how far we are from one wall to another in a given orientation, right? We have to define an orientation, because otherwise there's no orientation. We have to say, for example, in here, it's vector. It would be a vector with like 1 and 0, right? It would be like purely horizontal. We would need that. So you would need to compute the distance from where you are. Instead of computing the distance, am I crazy or not? I think I understand. I don't know how I will do that, but I think I understand. Instead of computing the distance like that, meaning you compute it like this, you would compute it solely based on an input vector, which defines the orientation, basically, right? It could be in that orientation if you want, or it could be what I was saying earlier is horizontal. But how do you know? Okay, how do you know How do you know? No, I don't know. That diff variable is already a vec2. Sorry to hate that. Yeah, don't worry. Strips, you want to hear something funny? I'm pretty sure you'll find it very funny. My notes page for room major has a new entry, V2. Rest assured, it's meant to be a very short V2, probably. Oh my god. Oh my god. So, the Book of Shader talks about cellular noise. Hey, you know what? Maybe we read that. Right? Maybe I'm gonna understand. Okay, cellular noise. In 1996, this is the year I was born. So this means that I should be interested in this. 16 years after Perlin's original noise and 5 years before his simplex noise, Stephen Worley wrote a paper, A Cellular Texture Basis Function. Arkham, the red, thank you so much for the donation. Are you crazy? This looks like a big jump from the previous goal. Are you crazy? This looks like a big jump from the previous goal. I don't have the notification, I can't see. Thank you so much. Thank you so much for the donation. 1996 you were born. It's the year I had my baccalaureate. Oh my god. I passed my bac in 2014, sorry. In 2014. But yeah, I was born in 1996. I'm 29 this year. Merry Christmas, or rather, happy birthday. Thank you so much, Arkham. Thank you so much for the donation. Andres NPR. Hi, Victor. How are you? Happy birthday. Thank you so much. Thank you so much, Andres, on YouTube. I was 6 years old when I had my back. So it's good. Nope. No, you were not. Wow. Thank you so much, Arkham. This is... thank you so much for your help. 1996, I was still in my dad's sack. Nope, I wasn't. No, I mean. We are 90% away from the goal. Would you look at that? Would you look at that, guys? We are 90% away. 90% away? No, we are 90% close. How would you say that? I don't know how to speak in English. I don't know how to pronounce, make a sentence, a correct sentence. But we are 90%. Anyway, you get the point, right? The goal is here, and we are 90% here. 96, I was unemployed, looking for a coding job and getting drunk with student friends. Really? 10% to meet the goal. Yeah, that's another way to say it. K Milos, thank you. 10% away. Thank you so much. So, thank you for continuing to help and patience with all of us. And by all of us, I mean me, obviously. Yeah. Okay, to understand the principle behind it, we need to start thinking in terms of iterations. Probably you know what that means. Yes, using for loops. There is only one catch with for loops in GLSL. The number we're checking against must be a constant, so no dynamic loops. The number of iteration must be fixed. Let's take a look. So points for a distance field. Cellular noise is based on distance fields. The distance is to the closest one of a set of feature points. Let's say we want to make a distance field of 4 points. What do we need to do? Well, for each pixel, we want to calculate the distance to the closest point. That means we need to iterate through all the points, compute their distances to the current pixel, and store the value for the one that is the closest. Okay, interesting. In my dad's sack of yours. Okay, so min distance is 100, a variable to store. Min distance, we grab that, and then we do the distance between our point and the point A. This is not very elegant, but it does the trick. Now let's re-implement it using an array and a for loop. In the total point, we grab the point and okay, note how we are using a for loop to iterate through an array of points and keep track of a minimum distance using a min function. Here's a brief working implementation of this idea. Oh my god! What the actual fuck? It moves. This is incredibly cool. Look at that. It moves. I want to add a gradient inside of each of my Voronoi cell. Wizardry. Yeah. Shader code is fucking wizardry. But maybe together we can actually understand something. Or maybe not. So in here we have our different cell positions. Okay. Interesting. We iterate through the cells. We keep the distance. What? What the fuck? Why is it following me? Why is it following me? Just a little segue from a shader noob. What's the big deal with shaders? You can do most of what shaders do with other means, right? So what's the point? It's because it's very fast to execute. You can't really do... That's not true what you're saying. You can achieve some of the same effects, some of the effects using like other ways. You don't have to do shaders, but shaders will definitely give you the possibility of doing things that can't be done otherwise. And also, yes, it's much faster. Like if you need to operate on a bunch of pixels, shaders are basically made for that. So you will be able to do some crazy stuff. Probably you can edit the code and see the result without scrolling. Yeah, probably. That's pretty cool. Okay, so we compute the distance. We iterate through the points. And we compute the distance. So for each cell, right? For each cell, we compute our position. So if I understand correctly, can I edit that? And I put this one at 0, 0. And so now I put the second one at 1, 0. Okay, I'm trying to understand something. Let me cook. Let me cook. I want to be at 0 and I want to be at 1. Ah, come on. And I want to be at 1, 1. Did I make a mistake? It's not doing what I thought it would do. It's not acting like I thought it would. I have a point top left, I have a point right top, bottom left, and bottom right. It's not doing what I thought because there's the mouse point. There is a fourth point, sorry. I didn't see that. There is a fourth point. Shit, that's not what I wanted to do. There is a fourth point. It's not doing exactly what I thought. Is it because this doesn't work? No, it works fine. Ah, stop. 0, 0 is at bottom left. 0, 0 is not at bottom left. 0, 0 is not at bottom left. 0, 0 is top left. You wrote 0.1 instead of 1. Oh, you're right. Thank you. Exactly, thank you. 0, 0 is at bottom left here. Really? No. What do you mean? I don't think so. Oh, no. Look at that. It is. Why is it? Why is it bottom left? Why is it at bottom left? It shouldn't be. No? It is. You're right. Look at that. I put only 1 point, and it's basically 0, which means that it's there. This whole top left versus bottom left is why so many games render everything upside down and flip before output. But in Godot, it starts. It's like drawing a screen, right? And when you draw a screen, at least in OpenGL, I guess, you start at 0, 0 in here, right? to me, bottom left as 0, feels a lot more natural. Godot's way is weird. Godot's way is normal. It follows OpenGL. Because a screen is drawn from top left. That's why. At least, it was. I don't know if it's still the case, but it was the case. You start at 0, at the top, and then you go... you go 1, 0. And here you have 1, 1. Godot follows OpenGL, that's why they're doing it that way. It's at the bottom left because it's meant to be confusing, so it feels more magical. Yeah, but okay. Happy birthday, Rodriguez, thank you so much. So, look at that. Now it works the way I want. So, this is exactly what I'm expecting. I'm expecting to create... I'm creating, for each pixel, we are computing the distance between our point. So, we have 4 points, right? 4 points. 1 in each corner. 1 in each corner. And for each pixel, we are computing the distance. And so when you are in the center, in here, the distance is the greatest. And then you have those lines created, because every time the distance is pretty big compared to the other ones too, right? Okay, so that makes sense. I understand that. I understand that. Shaders are best described as stupidly, mind-numbingly fast. Yes. So, this is cool. In the above code, one of the points is assigned to the mouse position. Play with it so you can get an intuitive idea of how this code behaves. Then try this. How can you animate the rest of the points? After reading the chapter about shapes, imagine interesting ways to use the distance field. What if you want to add more points to the distance field? What if we want to dynamically add and subtract points? Tiling and iteration. You probably noticed that for loops and arrays are not very good friends with GLSL. Like we said before, loops don't accept dynamic limits on their exit condition. Also, iterating through a lot of instances reducing the performance of your shader significantly. That means we can't use this direct approach for large amount of points. We need to find other strategy, one that takes advantage of the parallel processing architecture of the GPU. One way to approach this problem is to divide the space into tiles. Not every pixels need to check the distance to every single point, right? Given the fact that each pixel runs in its own thread, we can subdivide the space into cells, each one with unique points to watch. Also, to avoid aberration at the edges between cells, we need to check for the distance to the point on the neighboring cells. That's the main brilliant idea of Stevens Worley's paper. At the end, each pixel needs to check only 9 positions, their own cell's point and the point in the 8 cells around it. We already subdivide the space into cells in the chapter about patterns, random, and noise. So hopefully you're familiar with this technique by now. I am not. I am not. And I think this is something that I would need. Patterns. Oh, you just scale. Okay. Okay, you just scale. Hey, this is exactly what I need. Right? Guys, this is exactly what I need. I need to combine that, basically. I need to combine the whirly space with that. The Book of Shaders is a great way to teach people math in general. That's true, that's true. I think I should go through the Book of Shaders and just learn some stuff. Shaders is overall really good read. I saw Primer just didn't help going through it on his streams. And I'm planning to do it myself. Yeah, I should do it. I should do it. But that's kind of what we're doing right now, right? In my honest opinion, personally, I think I learn better that way. I'm not sure it's the most efficient, but I learn better by having a goal and then finding ways to achieve it. And so right now, I have the goal of recreating the shader from this game, right? Because I really think it's beautiful. It's very elegant. It's amazing. And so I'm excited to do that. And that drives me to learn more about some stuff. If I was just going through the Book of Shaders, maybe I would like not see why I'm doing it and not be interested. But anyway, let's continue that. So tile the space. we have a scale, and we do floor and fract. So what's the plan? We will use the tile coordinates stored in the integer coordinate ist to construct a random position of a point. The random2f function we will use receives a vector2 and gives us a vector2 with a random position. So for each tile, we will have one feature point in a random position within the tile. Ah, okay. What is fract? What is fract? Computes the fractional part of the argument. Returns the fractional part of x. This is calculated as x minus floor of x. Okay. And in here, we do floor. We do floor and fract. Hey, this is interesting. This is interesting. Doing fract is doing x minus floor. But we already have floor. It is here. It would be slightly faster to not reuse fract and use the result that we have in ist, right? It would probably be very minimal, but we are recalling the floor function when using fract. We can avoid that. We already have the result. But anyway, we don't care. And so how does this tiles the space? Maybe I should read about tiling really quickly. Yeah, okay, let me read about that really quickly, because otherwise I will be lost. In this chapter, we're going to apply what we've learned so far and repeat. Okay, the grid provides a framework within which humans' intuition and invention can operate, and that it can subvert. Within the chaos of nature, patterns provide a contrast and promise of order. From early patterns on pottery to geometric mosaic in Roman bath, people have long used grids to enhance their lives with decoration. Okay, first let's remember the fract function. It returns the fractional part of a number, making fract in essence the modulo of 1. In other words, fract returns the number after the floating point. Our normalized coordinate system variable st already goes from 0 to 1, so it doesn't make sense to do something like this. So they're grabbing st fractional part and vec of st. Okay. But if we scale the normalized coordinate system up, let's say by 3, we will get 3 sequences of linear interpolation between 0 and 1. The first one being 0 to 1, the second one for the floating point between 1 and 2, and the third one for the floating point between 2 and 3. Oh my god. Of course, I understand now. Yes, okay. Okay. Yeah. While the base UV goes from 1 to 0 to 1, sorry. We multiply that by 3, so now it goes from 0 to 3, but we don't care about that. At the end, we want it to be from 0 to 1. So we get the fractional part because between every whole number, between 0 and 1, we are going to get all of the fractions that are going to be able to basically recreate something that goes between 0 and 1, right? Okay, cool. Yes, okay. That's nice. Okay. That's how you do a pattern basically. With the gradient in between. That's neat. That's very neat. Okay. So that's what we do in here. La 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 la. So scale up the space by 3. Scale up the space by 3. Warp around 1 by getting the fractional part. Yes. Okay. And then we show the color on that ST. Wow, okay. Oh, Mattheus, thank you so much. Happy birthday. I was going to say happy birthday to you too, but probably not. But yeah, cool. Thank you for saying happy birthday to me. I'm just gonna open up because the cat is like screaming even though there's nothing. Give me a second. I do a very quick break. See you in 2 seconds.
Much better. Like when you charge the thing. Something that could be fun.
Okay. All right. So, okay, we scale that. Ooh, look at that. This is everything we need. This is everything we need. Now it's time to draw something for in each subspace. By uncommenting line 27, because we are multiplying equally in x and y, the aspect ratio of the space doesn't change, and shapes will be as expected. Try some of the following exercise to get a deeper understanding. Multiply the space by a different number. Try the floating point values, and also with different values. I don't care. Apply matrices inside a pattern. This is exactly what I want. Since each subdivision or cell is a smaller version of a normalized coordinate system we have already been using, we can apply a matrix transformation to it in order to translate, rotate, or scale the space inside. Yes. Rotate 2D. Okay, so in here we divide the space in 4. Tile basically multiplies our UV by the amount that we want, and then we use a matrix to rotate the space 45 degrees. We pass the thingy and we multiply by 0.25. What? The guy actually put a fucking thingy to scale it? Haha, this is so fucking cool. Okay, I understand the stuff. And then we draw a square. Draw a square. Okay, but I don't care. Rotate 2D is basically applying the rotation matrix, which is like very common stuff. Okay, I know what it's like. You're at the bus station and the guy who sells you the ticket, have a good trip, and you... do you too? Yeah. Shatters is a whole world. Yeah. This is very cool. So we know how to do that. Okay. Think of interesting ways to animate this pattern. Consider animating colors, shapes, and motion. Make 3 different animations. Recreate more complicated pattern by composing different shapes. Offset patterns. So now we'd say we want to imitate a brick wall. Looking at the wall, you can see half brick offset on X, and how can you do that? Okay. Wow. This is so cool. Ooh. Now that we've learned how to tell if our cell is an even or odd row or column, it's possible to reuse a single design element depending on its position. Consider the case of a truchet tiles, where a single design elements can be present in 4 different ways. By changing the pattern across tiles, it's possible to construct an infinite set of complex design. Pay close attention to the function rotate tile pattern, which subdivides the space into 4 cells and assign an angle of rotation to each one. This is exactly what we need. This is exactly what we fucking need. Remember this part for when you end up doing landscape materials. Yes, okay, that's how you break up the repetition on tiling stuff, right? Yes. Very cool. I didn't think about that. That's how you do it. To avoid having something that tiles perfectly and that looks very ugly, especially when you see it from above or from afar, you can just rotate it like randomly or whatever. Yeah. I bully artists about file names for a living, yes. This shader stuff, much GPU time. I don't know. I don't know how you consider the amount of compute time that a shader will take. I have no idea. Making procedural patterns is a mental exercise in finding minimal reusable elements. This practice is old, as we as a species have been using grids and patterns to decorate textile, floors, and borders of objects for a long time. Okay. This is very important. This is an important page for me. I need to go back to that at some point. Sorry. So what's the plan? So now we understand how we tile the space. Right? So what's the plan? We will use the tile coordinate stored in the integer coordinate ist. So ist is the floor. So ist, again, if we go back to the thing, just to understand, this is 0, 0, and this is 1, 0 initially, but we scale it, so it becomes 0, 0, and it becomes, for example, 3, 0. And the cool thing that we can do is with floor, we get this, basically. With floor, we get 0, 1, and 2. And with fract, we get everything that is in between. So we get another 0 to 1 in each cell. Okay, I understand. Lovely. I hope you understand too. And if you don't, I don't know. I don't know. So what's the plan? We use the tile coordinates stored in the integer coordinate ist to construct a random position of a point. Okay, that's how they're doing it. That's why you pass the thing to the random function. Fuck, I understand now. This is cool. We will use receives a vec2 and gives us a vec2 with a random position. So for each tile, we will have one feature point in a random position within the tile. Yes. That's how you start constructing the space. Okay, so what's the plan? Fuck, I read that already. Each pixel inside that tile stored in the float coordinate FST will check their distance to that random point. Yes, okay. We will need to check the distance to the point in the surrounding tiles, not just the one in the current tile. For that, we need to iterate through the neighbor tiles. Ooh, we don't iterate through the neighbor pixels. We iterate to the neighbor tiles. Yes, that makes sense. So not all tiles, just the ones immediately around the current ones. That means from -1 to 1 in X and the same in Y. A 3x3 region of 9 tiles can be iterated through using a double for loop like this one. Okay. And so, doing the check with the neighbor tile, neighbor tile allows you to have some sort of blending, I guess, between the things, right? Otherwise, you have this in here, you can clearly see the division. You can clearly see the division of your UV, and you can clearly see that it stops and it goes to the next cell. And so what we want is some sort of blending. I'm saying blending, but I don't know if it's the right term. Now we can compute the position of the points in our double for loop by adding the neighbor tile offset to the current tile coordinate. Now we can compute the position of the points on each one of the neighbors in our double for loop by adding the neighbor tile offset to the current tile coordinate. The rest is all about calculating the distance to that point and storing the closest one in a variable called mdist for minimum distance. Most implementations out there suffer from precision issues because they generate the random point in domain space, like world or object space, which can be arbitrarily far from the origin. One can solve the issue moving all the code to higher precision data types, or by being a bit clever. My implementation does not generate the point in domain space, but in cell space. Once the integer and fractional parts of the shading points are extracted and therefore the cell in which we are working identified, all we care about is what happens around the cell, meaning we can drop all the integer part of our coordinate away altogether, saving many precision bits. In fact, in a regular Voronoi implementation, the integer parts of the point coordinates simply cancel out when the random per cell feature points are subtracted from the shading point. In the implementation above, we don't even let that cancellation happen because we are moving all the computation to cell space. This trick allows one to handle the case where you want to Voronoi shade a whole planet. One could simply replace the input to be double precision, perform the floor and fract computation, and go floating point with the rest of the computation without paying the cost of changing the whole implementation to double precision. Dino Christ, thank you so much for the 2 month with Prime. Let's go. Welcome. Okay, interesting. So recapping, we subdivide the space into tiles. Each pixel will calculate the distance to the point in their own tile and the surrounding 8 tiles. Store the closest distance. The result is a distance field that looks like the following. Shit. But this is crazy. This is crazy. So what is not possible though? What is not possible though is for your point to go in another cell. There's always just one point per cell, right? Okay. Tile the space, minimum distance, we go through the things, we grab the neighbor, random position from our current plus neighbor, animate the point. So this is if we want to animate. We diff between the neighbor plus our point minus where we are, and we get the distance of that, and we keep the closest distance. Oh yeah, okay. We go through all of the neighbors and we get the closest distance. We go through all of the neighbors and we get the closest distance. Okay. Draw the min distance field. Draw the cell center. Draw the grid. Wow. Okay. Constructing Voronoi diagrams from cellular noise is less hard than what it might seem. We just need to keep some extra information about the precise point which is the closest to the pixel. For that, we are going to use a vector called endpoint. By storing the vector direction to the center of the closest point instead of just the distance, we will be keeping a unique identifier of that point. Okay, what? Okay, what? Let's do it again. I didn't understand that. We just need to keep some extra information about the precise point which is the closest to the pixel. For that, we are going to use a vector called endpoint. By storing the vector direction to the center of the closest point, instead of just the distance, we will be keeping a unique identifier of that point. Endpoint. Oh, endpoint, which is... Where is our point coming from? Point, it's the random index. And this gives us the exact thing if we have the same neighbor, right? And index UV is where we are in our cell. Okay, I understand. That point is the random point that you have, right, in your cell. You get it, or what? In your cell, let's say it's divided in 3. You computed a random point in here, in here, in here. And so in here, we just keep track of what point we are. Instead of just calculating the distance, we are also keeping track of which point we are currently looking at. That way, all of the pixels inside of here can compare it to this point, can know, hey, we are using the same point actually. We know that the closest point we are looking at is the same, so we could be the same color. That's how you assign a color to a cell. You compare it to the closest point. That's how you know you are in the same cell. Okay. Fuck, that's so cool. Note that in the following code, we are no longer using the min to calculate the closest distance, but a regular if statement. Why? Because we actually want to do something more every time a new closer point appears, namely, store its position. Line 32 to 37. Yes, we keep the closer distance, and we also keep the closest position. Add a distance field to the closest point, tint according to the closest point position. Show isoline, draw point center. So this is circular. This is circular, but we know... Okay. We have some knowledge. So you see, in my opinion, I don't know how you think about... about knowledge in general, but I see it as you start learning stuff, like in points, and then to have a greater understanding or to have more knowledge about something, like you start understanding stuff, is really when you start drawing lines between those different understandings, those different things. And so in here, I start to understand how the noise is calculated and how we're assigning the different cells. But in here, we also looked at how we're dividing the space and how we can map stuff into that space. And so now, at some point, what I need to do is use those two understandings and do, not really that, but create a line between the two. But that's really, really cool. And I don't think, unfortunately, I'm going to be able to do it today. And that's how you can do that. This is so fucking cool. Okay. Whoa! Note that the color of the moving cell, the bound to the mouse position, changes color according to its position. That's because the color is assigned using the value position of the closest point. RG is set to endpoint. Okay. Yes. Yes. And you could do BG if you want to change that. Okay. I never knew you can do loops and shaders. Always thought it is only math function. You can do loops. You can do as they discussed previously. You have to be careful though, because it's not necessarily super efficient. But very often you need more information than the current pixel, so you have to for loop, because you need to go and look at other cells above you, other pixels above you, or other cells above you. So you need to do that. Note how the color, like we did before, now is the time to scale this up, switching to Stevens-Worley's papers approach. Try implementing it yourself. You can use the help of the following example by clicking on it. Note that Stevens-Worley's original approach is a variable number of features point for each tile, more than one in most tile. In this software implementation is C. This is used to speed up the folio. Okay. So this is using a sine wave, right? This is using a sine wave, and that's why you have this circular motion. If you look at one point, you can see how it's basically creating some sort of circle. In this case, a squished circle, but it's kind of creating a circle-like motion. This is lovely. Once you figure out this algorithm, think of interesting and creative uses for it. Improving Voronoi. Okay, I think this goes above what I'm doing right now, and I don't need it. In 2011, Stefan Gustafsson optimized Stephen Worley's algorithm to GPUs. by only iterating through a 2 times 2 matrix instead of a 3 by 3. This reduces the amount of work significantly, but it can create artifacts in the form of discontinuities at the edges between the tiles. Take a look at the following example. Later in 2012, Inigo Quiles wrote an article on how to make precise Voronoj's border. Inigo's experiments with Voronoj didn't stop there. In 2014, he wrote this nice article about what he calls Voronoj, a function that allows a gradual blend between regular noise and Voronoj. In his word, what? Would it be... No, it's not what I care. I don't care about that. Then it's good. Yanis, hello. Why does Inigo Quiles sound familiar? Because he's Spanish, maybe? I don't know. Do you know him? Despite the similarities, the fact that is the way the grid is used in both patterns is different. Noise interpolates averages, random values as in value noise, or gradients as in gradient noise, while Voronoj computes the distance to the closest feature point. Now, smooth bilinear interpolation and minimum evaluation are two very different operations, or are they? Can they perhaps be combined in a more general metric? If that was so, then both noise and Voronoj patterns could be seen as a particular case of a more general grid-based pattern generator. Now it's time for you to look closely at things, be inspired by nature, and find your own take on this technique. Oh, this is how you create metaballs. This is how you create metaballs. It's always sign distance, right? Sign distance functions are crazy useful. And metaballs, I've been wanting to do metaballs for a very long time. And I think I have the understanding that I need to create that. From what I can see right now, from what I see, the metaballs that I see right now in here, in this example, I think I could recreate that by separating my UV space into grid. Right, into a bunch of grids, because if you look at one point, you can see it's basically moving. It's basically a point moving in its grid. And then you can compute the same way you compute the thing for Voronoj in here. You would compute the distance to the other point. And as you are closer to another point, you are bigger. Is that it? You are bigger? Maybe that's just it? I don't know, but okay. Okay, very cool effect. This doesn't do anything? Tissue. This looks like a crack. This looks like cracks. That's very true. Unicorn puke. This is so cool. People are so fucking intelligent. Let me tell you that. It's one thing to understand something that someone made, right? It's something, but thinking about it, this is very something. This is something else, right? I think it has come up before when you looked at shader stuff. Maybe. It's hard to learn shaders without running into Inigo. He's everywhere. Maybe that's why. Maybe we saw something. What are you even doing? I'm not really being paying attention. I'm doing that. So basically, with shaders, there is one cool thing that you can do with shaders is use a grayscale texture as a way to dissolve your texture. And so we've been experimenting with a bunch of stuff. For example, you can do a very simple linear wipe. We can do a very simple linear wipe if the gradient is just going from white to black, and you can just align it the way you want to change the way you're doing your linear wipe. So very simple technique, right? And with that, you can then use more complex textures to do more interesting stuff. So in here, for example, we have a much more complex noise texture. And what I want now is to combine that with the ability to have my own gradient on the Voronoj noise. And I want to be able to orient that texture, that gradient texture. That way we'll have something closer to that, right? We'll have something closer to that, but with the ability to have random orientation, which is going to be much more interesting. And all of that is because I want to reproduce the shaders that we see in this game. This shader is so beautiful. This shader is so beautiful. And so if I understand stuff, what you can also do then to make sure that you can have your base shader and then you can have noise texture on top of it that would be scrolling and that would only move part of the thing. Is it a shader though? It is for sure. It's for sure. It's so fucking cool. And the thing is, it's just a combination of some stuff. For example, in here, when they're doing the wipe in here at the end, when they're doing the wipe, you see how the things are reducing? It's probably a combination of having the gradient wipe on each of the cell and then having a bigger gradient that probably goes from the position of the bull and extends in a circle like that, and then you have your gradient like this, and you use that as a way to drive the other gradient. The thing is with shaders, it's all about combining stuff, right? It's all about combining stuff. You just have to be able to train your brain to see the effect as a combination of stuff, a layering of multiple effects. The same thing is true for art in general, but the same thing is true for particles and VFX, right? If you train your brain, if you train your eyes, you will see that most effects are actually just a combination of simple effects. And that's where it becomes magic, because if you don't have the eye, it feels like it's impossible to reproduce. But when you have the eye for that, you see how it's actually being layered. And then it seems simple, right? I think the thing I've learned from hearing you talk about shaders is whenever I want to be able to a game and put shaders in them, just choose a different game to build, because this stuff is way too confusing for me. No, you can just use shaders from other people. Maybe. That could be enough. For most people it can be enough. But I think anyone should start learning a bit of shaders. It's always good. You know, you can do a lot of cool stuff by knowing the basics, to be honest. If you know how to apply a texture, if you know how to mask using a texture, stuff like that, honestly you can do a bunch of cool stuff. And you don't need a lot to have some results. Okay, so I think I understand. Unfortunately, I won't do it today. So if you guys are interested in that, make sure to follow me. I might do it in another stream, but I will definitely talk about it again, right? Because I think it's pretty cool. And but I need to go now. It's quite late. So yeah, it's funny to recreate effects seen in game. Yeah, I understand what you're trying to say. And while I'm joking, I do think that as a game dev who do solo stuff is a lot harder to try to learn everything. It is, but it's part of the fun. It's part of the fun, in my opinion, is that you have so many opportunities to learn stuff. The secret to shader is to own and use a sketchbook that you put math in it. You think? Maybe. Okay. Yeah, I will need to think about that a bit more, but I'm excited. I think we have something cool. Guys, thank you so much for being here. I hope you enjoyed this little stream. I wanted maybe to play a game or something at the end, but it's a bit late for me. Thank you so much for the support, for the hype train, for everyone that, for the donation, Argam, and for the subs, Peacebreaker, Dino Christ, and others. If I missed you, thank you for the bits, Vex, and E5. Thank you guys for being here. Thank you for wishing me a happy birthday. Eat something very tasty for your birthday. I ate some cake, very good cake. Don't worry, it was really nice. And I will see you tomorrow. Tomorrow I will be streaming. We will do some Hyperslice development. Don't forget to check it out on Steam. That would be really cool. Yeah, for good cake. Yeah. So catch you tomorrow. Goodbye, and I will see you very soon, guys. Fuck, I launched the wrong thing. We will see you tomorrow. Okay. Wellaber streaming if you want to raid. Yeah, okay, let's go for a raid. Let's go for a raid with Wellaber. I don't want to launch this. Let's go for a raid with Wellaber. Let's go for a raid with Wellaber. Oh my god, Wellaber has a lot of people watching. He's been raided or what? He's probably he's been raided, right? He has a lot of people watching. But that's good. Anyway, let's go for the raid. Join the raid to get some channel points. Again, thank you for being here, and we are ready to raid. So let's freaking go and see you tomorrow. Goodbye.